What is acid rain? Acid rain is a broad term that refers to any form of precipitation, including rain, snow, sleet, hail, and even fog or dust, that contains unusually high levels of acidic components, primarily sulfuric acid and nitric acid. This acidity is measured on the pH scale, which runs from 0, very acidic, to 14, very alkaline, with 7 being neutral. Normal clean rain has a slightly acidic pH of about 5.6 because it reacts with carbon dioxide, CO2, in the air to form a weak carbonic acid. Acid rain is defined as precipitation with a pH of less than 5.0. Some extreme cases have been recorded with a pH as low as 2.0, 2.5, which is as acidic as vinegar or lemon juice. What causes acid rain? The primary cause of acid rain is human activities that release sulfur dioxide, SO2, and nitrogen oxides, NOx, into the atmosphere. 1. The chemical process. Sulfur dioxide, SO2, primarily released from burning fossil fuels, especially coal, in power plants and industrial facilities. SO2 reacts with oxygen and water vapor in the atmosphere to form sulfuric acid. Nitrogen oxides, NOx, released from vehicle exhausts, power plants, and industrial processes. NOx reacts with oxygen and water vapor to form nitric acid. These acidic compounds can then travel long distances with the wind before falling to the ground as wet deposition, rain, snow, or dry deposition, gases, particles. 2. Natural sources. Volcanic eruptions, wildfires, and decaying vegetation also release these gases, but human activities are the dominant cause of the severe acid rain problems seen since the Industrial Revolution. The effects of acid rain. The environmental impacts of acid rain are widespread and devastating. 1. On aquatic ecosystems. Lake and stream acidification. Acid rain flows into waterways, lowering their pH and making the water toxic to aquatic life. It can kill fish, frogs, insects, and other organisms, leading to sterile, dead lakes. Aluminum leaching. The acidity leaches aluminum from soil into waterways, which is highly toxic to fish and clogs their gills. On forests, nutrient depletion. Acid rain washes away essential nutrients and minerals, like calcium and magnesium, from the soil that trees need to grow. Toxic metals. It releases toxic metals like aluminum into the soil, which can damage tree roots. Direct damage. It can damage the waxy coating on leaves and needles, making trees more susceptible to disease, extreme weather, and insects. 3. On buildings and infrastructure. Corrosion. The acids corrode building materials, especially limestone, marble, and metal. Famous monuments and statues like the Parthenon in Greece and the Taj Mahal in India have suffered significant erosion due to acid rain. Paint damage. It can peel paint from cars and buildings. On human health. While not directly harmful like skin contact, the particles that cause acid rain, SO2 and NOx, can be inhaled. They are linked to respiratory illnesses like asthma, bronchitis, and other lung problems. Solutions and mitigation. The good news is that acid rain is a problem with known and effective solutions. Regulatory actions. Clean Air Act, USA. The 1990 amendments established a cap-and-trade program for SO2 emissions, which was hugely successful in dramatically reducing emissions from power plants at a low cost. International agreements. The Gothenburg Protocol in Europe set national emission ceilings for SO2 and NOx, leading to significant reductions across the continent. 2. Technological solutions. Scrubbers. Installing flue gas desulfurization, FGD systems, or scrubbers, in power plants to remove SO2 from smokestack emissions before they are released. Catalytic converters. Required in vehicles worldwide, they significantly reduce emissions of NOx. Alternative energy, switching from fossil fuels to renewable energy sources, solar, wind, hydro, nuclear, that produce little to no SO2 or NOx emissions. First, individual actions, conserving electricity to reduce demand from power plants, using public transportation, biking, walking, or driving fuel-efficient electric vehicles. Acid rain is a classic example of a transboundary pollution problem and a success story for international environmental regulation. While it remains a concern in some parts of the world, particularly in rapidly industrializing areas of Asia, significant progress has been made in North America and Europe to reduce its impacts.